Hello friends, in this video we are going to study about the algorithms of single linked list and circular linked list where we will perform the insertion and deletion at different places. The linked list is one of the challenging topics in the data structure. I will try my best to explain you in very simple way and with the help of examples. First, we will start with the insertion. We will perform insertion in the both single linked list and circular linked list. As you already know, the single linked list, how it will look like. For example, this is a node and second node is connected with first node. Like this, we have chain of the structure and finally we have null value in the end. First node will point to the head. First field will contain the data and second field will contain the address of the next node. Again, in the second field, we will have address of the 4. And here, the last node will contain the null pointer. This is the single linked list. And if we connect last node with the first node, if we do not do null pointer here, and this node, if we connect with the first node, then it will become the circular linked list. So, when we study about the algorithm of single linked list, then most of the steps of circular linked list also same. So side by side, I will try to explain both the algorithm on the same slide. So let's start. In every algorithm, we are not going to create node every time. So I'm explaining this node creation here. In the single linked list and circular linked list, we will be having two fields, that is data and the next pointer, the address of the next node. So this I can create by using the malloc function. If we create malloc function, then the structure of the node will be created in this form. We are having two pointers. One is we are keeping for head, that is first node, and the PTR will always contain the new node. So whenever we are going to insert the new node, our first node, the new node will point to the PTR. Now, let's start with the algorithms. In this algorithm, we are going to insert a node at the beginning of the linked list. So let's take one example here. I'm taking three nodes here, which is already there in the linked list. Value are 2, 3, and 4. Now, I want to insert a node at the beginning of the linked list. So let's suppose I want to insert 1 here. Okay. So this node, as I told you, this node will be pointed by PTR. That's why name of this node is PTR. So step 1, just for checking that if PTR is null, then we will say that memory is not allocated. So memory should be allocated before insertion. So that is the step number 1 we are going to check every time when we insert the node. Step number 2. Here we are going to take one more pointer, that is new node. New node we are going to take because whatever operation we are going to perform with the help of new node only we are going to do it. For 5 we are not going to take PTR. In the step number 3 we are doing PTR is equal to PTR to next. The reason we are doing PTR is equal to PTR to next is that when we insert another node, then this PTR will point to that next node. If we do operation with the help of PTR, then new node will be assigned, will also come on the PTR. That's why PTR we are not going to use further in the step number 4. And the PTR will be free node. It will point to any free node when the new element will come. Now, you know that we have to insert data here. Right now, data is not present. So, we are taking step number 4. In the step number 4, we are writing that new node to data is equal to value. So whatever value will be coming here, that will come on the data field. So this step number 4 will always come when you want to insert the data in the new node. Next, next thing we have to do is we have to connect this new node with the 2. So 1 I want to connect with 2. So in simple way, if you want to write, you can say that I want to do 1 to next is equal to 2. Now you know the name of the one. The name of the one is new node. So we are doing new node to next is equal to 2. And 2 is your head. That's why we are writing step number 5. Step number 5 is new node to next is equal to head. Now this node is now connected with the 2. Finally, this is we have to bring head here. Why? Because this is now our new first node. So what I will write? Head is equal to new node. Finally, step number 7 is exit. So in this way, we can insert the new node in the beginning of the simply linked list. So next we are going to insert the node at the beginning of circular linked list. So let's take one example. Here we are having 3 nodes in the circular linked list. 1, 2, 3, and this is a circular linked list. So 3 will be connected to the 1, and the 1 is your head node. Now you want to insert any other node at the beginning. Let's suppose I want to insert 4 here. So the step number 1 to 4 there will remain same only. PTR is equal to null, means we are checking whether memory is allocated or not. We can say write overflow also. Step number 2 is your new node is equal to PTR. Means here this was PTR, so we are assigning here new node also, so that we can do operation with the help of new node. Step number 3 is you set PTR is equal to PTR to next, which we will reserve for another use. Step number 4, new node to data is equal to value. So here I can write the value in the data field of the new node. Now, step number 5, why is temp is equal to head we are taking? Here, why we are writing temp here? Why? Because I want a variable here or pointer here so that I can connect 3 with the 4. And we should have the name of the node. If we don't have name of the node, then we cannot connect it. That's why we have to bring this temp here so that I can connect 3 with the 4. So temp is equal to head we are writing. In the next field, I will do temp is equal to temp to next. So if you do temp is equal to temp to next, then this temporary variable will come here. Then again we have to repeat it. So how many times you are going to repeat it? So I will write step number 6, repeat step number 7, while temp to next node is equal to head. Means the temp to next will be head, then it will stop. So our temp variable will come on the last node. In order to bring the temp on the last node, we are writing step number 5, 6, and 7. Finally, we have to connect 4 with 1 and 3 with the 4. So what we will do? New node to next is equal to head. The new node to next is equal to head we are going to do. Then temp to next is equal to new node. Means this temp to next. Okay, you can say the 3 to next. 3 to next I want is what? 4. So what is 3 here? 3 is temp. So it is temp to next. What is 4 here? 4 is our new node. So this step number 9 is basically 3 to next is equal to 4. Finally, we will make this as a head node, and this link will come here because this will be your first node in the linked list now. Finally, step 11 is exit. Now, we are going to insert the node at the last position of the syncing list. So let's take this example where we have three nodes, 2, 3, and 4, and we want to insert the node here at the last position. So step number 1, 2, 3, and 4, they are the same only. Means we are going to check if PTR is null, then we will write overflow because the memory is not allocated. Step number 2 is new node is equal to PTR. Means this PTR I have given the name new node. So this is the name of this node will be new node. Then I'm going to insert some value here, that is new node to data is equal to value in the step number 4. Then, if this is the last node, then we have to write this 5 to next is equal to null. And 5 to next means it is the new node to next is equal to null. So step number 5 is set new node to next is equal to null. Now we have to connect 4 with the 5. We can say 4 to next is equal to 5. But the name of the 4 we don't know. So we have to give some name to the 4. So what I will do, I will bring the temporary variable to the fourth position or fourth node. So if we bring the temp here, first I want to bring temp on the head. So I will write temp is equal to head. And then I will bring the temp on the fourth node. That is here, last node. So what I'm going to write? Repeat step 8 while temp to next not is equal to null. When temp to next is equal to null, then we will stop. That's why this temp is equal to temp to next. It will happen 2 times and then temp will come here. So this loop will stop. After that, simply we can say the name of the 4 is temp. I can say temp to next is equal to new node. So temp to next is equal to new node we will write, and the step number 10 is exit. Here it will come 10. So in this way, we can insert the node at the last position of the synced list. So step number 9 is basically we are connecting this 4 with the 5. Now, let's suppose we want to insert the node at the end position of the circular linked list. So you can see this example here, this 4, 5, 6, we have node, and this is circular linked list. So 6 is connected to 4. So we can say that 6 to next is equal to head here. But we want to insert the node at the last position. So the first 4 steps, as you can see, that is same only, which we have done till now. So step number 4 will give the data to this pointer. And step number 2 will assign this as a new pointer, that's new. Now, what we will do? You know that we have to connect 6 to next should be 7. And I want the 7 to next to be 4. These two are the main steps we have to do. For that, what we have to do, again we have to do is, we have to bring some temporary variable here. And in order to bring the temporary variable here, we are going to write these steps as it is. So step number 6, we will start. Okay, so that's temp is equal to head. Initially temp is here. Step number 6, repeat step number 7 while temp to next not is equal to head. You know that the temp to next is equal to head right now. So till here, this step number 7 will work. So temp is equal to temp to next we will do 2 times, then temp will come on the last node of the circular linked list. Finally, we can do this task now. How we are going to do this task? The name of the 6 is temp. You know that we have to write temp to next is equal to 7. 7 is what? New node. So here it will come temp to next is equal to new node. You can see step number 9. So this node will be connected with this step number 9. Then We'll write 7 to next is equal to 4. 7 to next means new node to next. And new node to next will become add. You can see in the step number 8. This was your step number 8 and this was step number 9. And finally, what we will do, we are setting head is equal to new node. So the head is equal to new node will not come. So in this, step number 9 will not come because we are inserting the node in the last position. So in this way, we can insert the node in the last position. So the main steps are in this algorithm is step number 8 and 9, which we are doing connections. Now, let's suppose we want to insert the node at any particular position. Let's suppose the position number 3. So let's suppose we are inserting any node here after 6. So what we are going to do? So step number 1. Step number 1 is the same only, that is if PTR is null, we cannot insert the node. Step number 2, that we are setting this PTR to the is equal to new node. So this will be our new node. The new node to data is equal to value, means value will come here on the new node. Then you know that if we want to insert the node at any position, then we have to bring some pointer here. So how we are going to bring the pointer? With the step number 4, temp is equal to head we are going to write, and then we are going to set some index. For example, I want to insert the node at third position. So I will set the index is 3. So the repeat step number 7 and 8 is index minus 1 times. Or here you can write till the desired node where we want to bring the nodes. According to that, we can run that step number 7, 8. So step number 7 is temp is equal to temp to next. Step number 8, why we are doing this temp is equal to null? Because if if we want to insert the node at 10th position, and if we have less number of nodes in the linked list, then we can print that desired node is not present. Because before that only we will get temp is equal to null. That's why step number 8 we will always check every time that the temp is present or not. So finally, the temp will come after the step number 8. Now, we have to do is just we have to connect 6 with the 7. So if you want to connect 6 with 7, you will write 6 to next is equal to 7. If you want to connect 7 with the 8, you will do 7 to next is equal to. So you have to remember that this step we are going to do first. We are going to connect this 7 to 8 first. Because we should have link of this temp here. That's why this will be your next step. So you can see what is 7 to next. 7 means 7 is your new node. The new node to next is equal to 8. What is 8? 8 is your temp to next. This value is your temp to next. So instead of 8, I'm going to write temp to next. So new node to next is equal to temp to next. And this is your step number 9. When I do 6 to next is equal to 7, 6 is your temp and 7 is your new node. So simply you will do temp to next is equal to new. So this is your step number 10. So step number 9 and 10 are the main steps. The other steps we are already repeating from the previous algorithms. So just you have to take care of step 9 and 10. Now let's suppose we are going to insert the node in any specific position of the circular linked list. Again, the scenario is same only, just the difference is this 5 is now connected with the 2. So if you want to add anywhere in the node, then your algorithm will remain same only. You see step number 1 to 4, that is also same. And the step number 4 to 8, only one change we are going to do, that if we want to check if temp is equal to head, then desired node is not present. Right now, I want to insert the node at the third position, and we have only third three elements. If I tell you insert the net node at the 10th position, so I will not be able to do it. So if you want to bring temp is equal to temp to next, it will come on head once. So in this case, I can say that we don't have 10th node. The desired node is not present. And we can go to step number 11, that is exit. So here we are changing just one thing, that in the singly linked list we were checking null, and here we are checking head. Remaining steps are same only. Now you can easily connect this temp with the new node which we have done in the singly linked list. So same to same your answers will come. You can check that new node to next is equal to temp to next we are doing, and temp to next is equal to new node. Now we will see how can we delete the node from the linked list in from the circular linked list and singly linked list both. Let's see. First start with the singly linked list, and I want to delete the first node of the linked list. Let's suppose we are having two nodes here in the singly linked list. So I want to delete the two, that is first node of the. So step number one, first of all, we will check if head is done, means there is no node present, so we cannot delete. So we will write linked list under flow also, and we will go to exit. That is step number 5. If you want to make this as 3 is a head node, then what we have to write? And we have to write head is equal to head to next. That you know that you want to bring head here, you will write head is equal to head to next. But we have to bring one more pointer here, that is PTR. Why? Because if we want to delete the node, we have to free this node. And for doing free this node, we have to bring some pointer here. So we will do PTR is equal to head first, then we are going to do head is equal to head to next. So your head will come on the 3. Finally, you can do free PTR and you can exit. In this way, this node will completely be removed from the memory. Now, let's suppose this is the circular linked list is given, where we have 2, 3, 4 are the node in the circular linked list. I want to delete the first node from the circular linked list, so I want to delete the 2. So if you want to delete first node from circular linked list, so step number 1 will always come. That is, if head is null, we cannot delete the element. Second thing, if we will delete 2, then we will have some new link for this 4 to 3. So for that, what we are going to do is we have to bring some pointer on this location. Some pointer PTR will come on this location. So how do I bring this PTR here? As we have done earlier also, that if you want to bring PTR here, first we will assign PTR on the head. So I will write PTR is equal to head. Then I will do PTR is equal to PTR to next. If I do that, PTR will come on this. But this step I am going to repeat in the loop. And this I am going to do how many times? Till we will not get PTR to next not is equal to head. Till that point of time, we have to do PTR is equal to PTR to next. And that way, PTR will come on the last node. So, the step number 2, 3, and 4, which we are doing for bringing PTR on the last node. PTR is finally here. What we can do now? Now, if you want to connect 4 with the 3, means I want to do what? 4 to next is equal to 3. What is 4? 4 is basically your PTR. So I'm going to write PTR to next. And what is your 3? 3 we can write head to next. So this is the new step which will give us connection between last node and head to next. Now we can free head and we have to make this node as a head also. So if you want to bring 3 as a head node, we can do is head is equal to ptr2 next. But before that, we will free the head node. So step number 5 is ptr2 next is equal to head to next. And step number 6 is we are freeing this head. And finally, we are setting the new head, that is head is equal to ptr2 next. This head will come. So in this way, we can delete the element from the beginning of the circular linked list. Next is, if you want to delete the node from the last position of the linked list, how we are going to do? Let's suppose we have some set of nodes in the linked list, 2, 3, and 4. If you want to delete the 4, then you know that we have to bring null here. So what we will do, we will require here 2 pointers. One is here I want one pointer ptr, and here I want one more pointer, that is 3ptr. But that is the main thing, that how we are going to bring the ptr and 3ptr here. For that, what we will write? First, we will assign ptr to the head. So ptr is equal to head we have done. Now we are going to repeat the step number 4 and 5. What is step number 4? Step number 4 is pre-ptr is equal to ptr. Then we will do ptr is equal to ptr2 next. This pointer will come on the next node. So pre-ptr and ptr now 2 and 3 respectively. This process I am going to repeat till the ptr2 next node is equal to null. So ptr2 next is equal to null, then we will stop. So if one more time if you do it, then this step number 4 is pre-ptr is equal to ptr. Both are same now. But if you do step number 5, ptr will shift one more step forward. Finally, ptr and pre-ptr will come on the 3 and 4 respectively. Finally, 3 is your pre-ptr and 4 is your ptr. Now we can easily free the value of the ptr, and we will assign this 3 to next is equal to null. What we have to do? We have to do pre-ptr to next is equal to null and free the ptr. You can see the step number 6 and 7 here. Pre-ptr to next is equal to null and 3 ptr. Then finally exit. Now we are going to discuss about the circular linked list and how we are going to delete a node in the last of the circular linked list. Now you know that step number 1 is same only. Okay, let's suppose we have some circular linked list here, and I want to delete 4 from the linked list, but 4 is connected to the head. So if you delete that, step number 1 is same only, that we are checking if head is equal to null, then we will write underflow. Then same thing we are going to do it, that ptr we have to bring here and pre-ptr we will bring here. This will be done by the step number 2, 3, 4 and 5. Now what we have to do? Now we have to set this 3 to next is equal to 2. So 3 to next I want here now. 3 to next is equal to 2. And 4 we have to free. So it's very simple. Just we have to write pre-ptr to next is equal to head, because 3 is your pre-ptr and 2 is your head. So pre-ptr to next is equal to head, free ptr. And finally, step number 8 is exit. Now let's suppose we want to delete the node from any particular position. or any specific node I want to delete. For example, second node I want to delete. Then what I have to do? If I want to delete second node, you know that practically we want 2 to be connected to the 4. Then how we are going to do it? So here also we have to give the name of 2 and 3 so that I can connect 2 with the 4 and 3 I can free. So initially I will check if head is equal to null, then I will go to step number 10, that is exit. Step number 2 is ptr is equal to head. Then we will bring ptr on the position of 3. ptr I want to bring on the position of 3 and one pre-pointer I'm going to tag that will connect with the 4 later on. The steps are same that we have to repeat step number 5 to 8 until the index. The pre-ptr is equal to ptr, ptr is equal to ptr to next. If ptr is null, then we will say desired node is not present. Because we are going to delete, let's suppose, 6th element. 6th element is not present. So ptr will become null. And if ptr will become null means desired node is not present. So we'll go to step number 10, that is exit. Now we are ready to make connections. How do we make connections? See, if you delete 3, then you know that we have to write 2 to next is equal to 3 to next. 2 to next will become your 3 to next. What is 2? 2 is your pre-PTR. So pre-PTR to next is equal to what is your 3? PTR. PTR to next. That will be your next step. So in this way, we are going to connect with this. And finally, we can do step number 9, that is free PTR. So this node will go and deallocate the memory. Now we are going to delete the element from the circular long list. So if you want to delete, let's suppose 3. So we are going to do same thing which we have done here in the singly linked list. We are going to take pointers and finally we'll connect 2 with the 4. So there is no changes except you can see here one change will be there, that this list is now circular. PTR will become head if the number of nodes are not present. Desired node is not present and PTR will become head. And if PTR is become head, then we can go to step number 10, that is exit. So only one change will be there in this linked list. That is your PTR is equal to head. Rest of the steps are same in the circular linked list. So one extra step I have added here, that is step number 4. What is step number 4? If index is 1. If index is 1 means only we have single node in the linked list. So if there is a single node in the linked list, simply the first node is connected to the first node only. The first node is connected with the first node. In that case, what we will do? So if PTR to next is equal to head, means here is your PTR. Why here it is PTR? Because of step number 2. PTR is equal to head. So PTR to next is equal to head. Means simply you will do free PTR. And we will set head is equal to null and go to step number 11. Means we don't have anything left now because head is null.